Hi, welcome you all for the session object cloning. The object cloning is one of the approach to make the exact copy of an already existing object. For that, we will use the clone method of object class to create that exact copy of an existing object. The syntax is given here for the clone method, which is protected access specifier. Object is the class, then we are invoking the method clone. If there is any exception is occurs, then clone not supported exception is throwing in the program. Here the Java package is having the sub package language. Then in that we are having the clonable interface. It should be implemented by the class where the user needs the object's clone. Then if that class is not implementing the clonable interface, okay, then which is generating the clone not supported exception, this line, right? So here you see we are making the syntax. Public is the access specifier, class name is the sample, then which is implementing the clonable interface, right? So here it will not generate this exception because which is implementing the clonable interface. Suppose if we forgot to give this statement implements clonable interface, then it generates the exception clone not supported exception. Then inside that we can write any number of statements. We will see the example in next slide. Why do we use the object cloning? The clone method saves the extra processing task for creating the exact copy of an object, because when you are using an object to create the a new copy by using the new keyword, then it will take more processing time than when you are using the clone method. The object clone is protected access specifier, so we cannot call this clone method directly. So instead of that, we will call the object dot clone method from the child class indirectly. If user writes a clone method in the child class, then all of its superclasses, that means parent class, should define the clone method inside those superclasses. Object.clone is supporting only the shallow cloning or shallow copying. But if we need deep cloning, then we have to apply the method overriding concept, that is polymorphism concept. Then we will see now the example here. The class is the keyword, then we are defining the class name of sample obj, which is implementing the clonable interface, so it will not create that clone not support exception. Then I am defining the variable id belongs to integer data type. I am initializing the value 1257. Then I am creating the constructor. Method is having the similar name to the class name, so we are calling that is a constructor. So constructor is having the variable id equal to 1247. Then I am defining the main method here, which is passing command line arguments as a string data type. Then here I am using the try catch exception for catching the exception if there is occurring. Then I am creating the object o1 by using the class sample obj, right? Then here I am trying to identify the object value, what is the id of this object o1. So you see, which is defining the value 1247, because here that 1247 is the value. Once you are calling this o1 dot id, the o1 is created by using the sample obj. So sample obj is here, which is the constructor. So constructor is available here. The constructor is having the value 1247. Then the statement which is returning original object, then constructor value original object 1247. Then I'm creating new object here o2, right, which is cloning the object o1, right? Here o1 is available. O1 is having the value here 1247. Then I'm copying this exact copy of this O1 to the O2. That is the statement here given by using the clone method. Then I am calling the value O2 dot id. So O2 dot id just returning the value, right, which is having in the O1. So here cloned object is also having 1247, right. If there is any exceptions error occurred, it will be catch by try catch statement. Then it will generate the exception by using the variable e. Then we are printing the value which is available in the e, right. This e is belonging to the class clone not supported exception. So here we are using the clone method to make the copy of the existing object O1 into the new object O2. Here one more example we are giving by using equal symbol. So we can make the copy, we can clone it by using two things. One is equal symbol and another one is cloning method, right. So here we will use object dot clone. Okay, object dot clone, but here we are simply assigning the value. So here same thing, we are defining sample obj implements clonable. Then constructor is defined as I explained in the previous example. So O1 is created by using the class sample obj. Then I am printing the value O1 dot id, right. So then here just I am assigning the value to O2. So here which is also giving the value O2 dot id. So then now we will see the output, right, here by using the same O1 and O2, but symbol we are using assignment symbol. This given output as a error because here we are not using any clone method. Okay, so since we are not using clone method, right, which is generating the exception, clone supported exception is never thrown in the body of corresponding try statement. So here we didn't use clone method, that's why it is generating the output. So what we have to do, we have to simply remove this implements clonable statement and this try statement, right, and this catch clone not supported, and this one and this one. So if you remove this, then you will get the output this 1247 for O2 and O1, right. And now what is the difference between clone method and equal symbol when we are using when you are creating the new object obj by using the class tiger, it is generating the object and alerting the memory locations in the heap and making them reference to that particular variable obj by using that object. When only one tiger object is existing on the heap memory, but we want to make the reference to the same tiger by using two variables, then we can use equal symbol. You see single tiger is there, but we are making the reference by using two variables. Already one is obj, and here we are assigning this whatever value available in the obj to the obj2. Okay, so here we are making single object tiger is available, but we are making using two variables. One is obj and another one is obj2 to refer that particular tiger, single tiger, right. And here we are if you want to create new object variable on the heap by using the class tiger with the same variables and values, right, then we can link that reference to the object second variable obj2. So for that we can use the clone method here, right. So here the object variable we are creating obj2 second variable, but values whatever available in the obj that will be available with obj2. So now if you want to change the value for the obj2, you can change it, right. So because it is referring the different tiger, Okay, different tiger, so you can give the different values which are not available in the obj, right? First variable. So based upon that, if you want to see which is the uh, object running in the current JVM, by using the R1 it will give you get runtime. Then if you want to see what is the total memory available in the Java environment, that will be given by total memory method. Then what is the free memory after consuming some memory location for the obj1. So like that, when you are creating the object variable, some memory locations will be allotted to this variables. Okay, so after allotting, what is the free memory is available in the heap, that will be given by free memory method. So based upon that, we will see the example. Here you see, as I told you, after removing the implements, right, implements clonable, then you will get the output for this example by using the equal symbol, right? Now we will see the free memory locations and memory consumption for how we are allotting for this object cloning here. First we will see the class test1, and we are defining the variable x here. Test2 is the class I am creating, then which is extending the class test1. Okay, so inheritance concept, this is parent class, and this is child class. Okay, then which is implementing the interface clonable, this is clonable interface, built-in interface available in the object class, right? Then we are creating one variable with integer data type. Now you see, I am calling the method clone from the class object, and which is throwing the clone not supported exception if there is any exception occurs. Okay, then which is returning super dot clone. Super means parent class. Okay, parent class is here the test1, right? Then I am creating the driver class main. Inside that I am using the try catch block if there is any exception occurs. Then here I am creating the first object t1 by using the subclass test2, right? Then I am assigning the values for that object dot variable name 10. Here for x variable I am using the 30, right? Then I am applying the clone method. So whatever values available in the t1, I am transferring to the object t2, cloning, just copying, make the copy, exact copy. So now t2 will have two variables, t2 dot a, t2 dot x. So whatever available in the t1, so t1 is available with the two variables. Okay, so now t2 dot a is 10, t2 dot x is now 30. After this step, here I am modifying the value of t2 dot a. Okay, here I am overwriting the value 100. So now 10 is overwritten by 100. Then t2 dot x I am making 300, so overwritten by 300, right? So now the values are replaced by new values. Now I am trying to print the values here, object, original object t1 values I am printing here. t1 dot a is 10, t2 dot ax is 30. Likewise, cloned object t2 dot values I am printing here. Updated values t2 dot a is 100, t2 dot x is 300. If there is any exception, it will give you that exception by using the variable e. So now you see the output is given, right? T1 dot values 10, 30, then cloned object t2 dot values 100, 300. So this is the way how we are making the cloning. After cloning, if you want to update the values of cloned object, you can do that. Likewise, here if I want to know the memory consumption for each object, here base class is created, then variable integer assigning with 100 value, and here class is created, driver class which is having the main method. Then b1 is the object I am creating by using the class base. After that, I want to know what is the object currently running in the Java runtime environment, so that is assigned to R. Now I am assigning the memory total memory of the current runtime environment, Java runtime environment, memory 1 variable. Just I am printing the memory 1. So you see here I got the value total memory is 266338304 based upon this statement, right? Next I am printing the value for the b1.x. So b1 is created with respect to base class. So base class is having the value 100 in the variable x. So now I am printing the value. So b1 is here 100. Then here I want to see what is the free memory location after assigning the memory location to the b1. Okay, so here after assigning the memory location to the b1.x, so 100 is stored here. So for that we consumed some count of the memory location. So after that you see what is the free memory for available in the current runtime environment. So you see 263 777 616. You look at that here, the difference. So this is the difference, right? So now I want to see, right, the difference, how much memory is occupied for the b1.x. Okay, so here for that now free memory is available. This is subtracted from the total memory. So total memory minus free memory. So I got this value. So that is the value you see here. You will get that, right? So that is the memory occupied by the object 1 b1, right? So now I'm creating the next object b2 by using the uh, base class, right? Then now I have two objects, one is the b1 and another one is b2. I am checking, right? So both are equal or not. Both are not equal because b1 is stored in some memory location, b2 is stored in another memory location, even though which may have same values, similar values, but which are stored in different memory locations. So it will give you false. Both are not equal. But you see the word welcome is equal to the word welcome. So both are having combination of caps and lowercase letters, both are similar, so it is giving you true, right? So here we can check the total memory consumption of each and every object and remaining memory locations of the Java runtime environment by using the methods free memory and total memory. Now you see I am checking the comparison of objects here. Base is the class I have created, x is the value 10, child is the class name I am creating by using the inheritance concept. The parent class is here base. Okay, then main method is there. I am creating the object b1 by using the parent class here base, and b2 one more object I am creating. Now for b1 I am assigning the value 10, then which is printing by using the print statement. That's what given here. Then for b2 I am we are assigning the values x, that is also printed by using the print statement. Now we are checking, right? b1 also with the 10, b2 also with the 10, right? But when you are checking the equal comparison, which is giving you false. Why? Because b1 is the object. Okay, b1 is the object. So this b1 is stored in another memory location, b2 is stored in different memory location. So both are different objects which are stored in the memory location, even though both are having same values 10, but both objects are different. That's why, right, which is returning here false. Okay, so that is the comparison of the objects, right? But when you are having integer variables, simply b1 integer b2, then you are assigning the values, then it will give you true. Okay, but here you see both are objects, not a integer variables. Okay, thanks for watching.